Okay, for geometry 3.4 notes, we are talking about parallel and perpendicular lines. So we're going to look at just a few theorems first. The first one says if two lines are parallel to the same line, then they are also parallel to each other. So if A is parallel to B and B is parallel to C, then A is parallel to C. It kind of feels like the law of syllogism, but it just states that if two lines are parallel to each other, then they are also, the first one is also parallel to the third one. All right, the next theorem is in a plane, and this is important, it has to be within the same plane. If two lines are perpendicular to the same line, so if M is perpendicular to T, excuse me, and N is perpendicular to T, then that means they are parallel to each other. So then M and N would be parallel. So if M is perpendicular, I don't know if we've looked at that symbol yet, but an upside down capital T means perpendicular. So, and that means 90-degree angles. So if M is perpendicular to T and N is perpendicular to T, then M and N are parallel to each other. So again, these are kind of common sense things, but these are the theorems that we're going to be using in this lesson. The last one that you should know is the perpendicular transversal. So in a plane, and again, it has to be within the same plane. If a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other. So if N is perpendicular to L, so if N and L are perpendicular right here, and if L is parallel to M, so L is parallel to M, that's why the little arrows are here, then that means N is also perpendicular to M. So N is also perpendicular to M. Excuse me. Okay, so let's try to use these problems. Carpentry. A carpenter plans to install molding, like crown molding, on the sides and on the top of a doorway. So here are the sides, and here's the top of the doorway. The carpenter cuts the ends of the top piece and one end of each of the side pieces at 45-degree angles. Okay, as shown. Will the side pieces of molding be parallel? So will this side be parallel to this side? So if you guys put together the two corners that are 45 and 45, that would make a 90-degree angle. And same thing here. These would also be 90 degrees when you put together 45 and 45. So based on our theorem that if two lines are perpendicular to the same line, so if two lines are perpendicular to the same one line, then that means they are parallel. So I'm just going to put theorem 3.9 here for my explanation, but this is a yes. And I'm just going to abbreviate theorem 3.9. But again, you can go up and double check why that is. It's in the same plane. Two lines are perpendicular to the same. This one's perpendicular and so is this one to this. That means they are parallel to each other. Okay, let's look at the next one. Can you assemble the pieces below to form, excuse me, I need to clear my throat. Can you assemble the pieces to form a picture frame with opposite sides parallel? So in order for opposite sides to be parallel, we need to be able to make 90-degree angles. So 60 plus 30, 30 plus 60, 60 plus 30, and then 30 plus the other 60. So this is again a yes, because each corner would be 90 degrees. And again, I'm not going to make you guys write out all of that explanation. As long as it's making sense to you, I hope it does, but all 90 degrees would make a rectangle or square. It would make 90-degree angles. So yes, the opposite sides would be parallel. So you can explain it with this picture because they're all 90 degrees. All right, let's look at the next page. All right, this one's an error. It's error analysis, which means somebody did something wrong. So a student says that according to theorem 3.8, that is this one, two lines are parallel, then they would be parallel to each other. So according to that one, if line AB and line BC must be parallel because they are both perpendicular to BF. So AB and BC. Here's AB, and here's BC. Those would definitely not be parallel, but they are both perpendicular to BF. Okay, I understand how they're both perpendicular to BF. So this one's perpendicular here, and this one is also perpendicular here. However, these lines would not be parallel, and that's a couple of different reasons. So the first reason is because theorem 3.8 doesn't really talk about anything perpendicular, so they're wrong on this theorem. If anything, it would be one of these theorems. So first error is that they're wrong on which theorem it is. It's not the parallel to parallel, meaning they're parallel, because this is not all parallel anyway. So that's one of the reasons they're wrong. And the other reason is because this is not the same plane as this other one. So I'm going to write that because I think that's probably what they meant. So I'm just going to say something like they must be in the same plane. But that's not the only reason this person's wrong. However, all of these theorems are only if they are in the same plane. Okay, a puppeteer cuts the pieces shown at the right to frame a stage of a puppet theater. Will the sides on the left and right be parallel? So again, 60 plus 40 definitely does not add up to 90. That is 100, and so is that. So this is not going to be a 90-degree angle, so this is going to be no. And then I will let you write it out, or as long as this makes sense to you, they are not right angles. So they need to be perpendicular for these two side pieces to be parallel. Okay, you can pause the video and write all that out if you want. As long as you understand it, we can move on. All right, last part. This says a developer is planning a new housing complex. The map of the complex is shown right here. This kind of reminds me of your little project you did recently. Assume that all streets lie in a plane. So all streets are lying in the same plane. So we know that for sure. Here's part A. If Washington and Lincoln are to be parallel, Washington and Lincoln, so if these are supposed to be parallel, what must be true of angle 1 and angle 2? So here's 1 and here's 2. So in order for these to be parallel, 1 and 2 must be right angles. They must be right angles, or you could call them 90-degree angles. Okay, letter B. Which streets must be parallel if angle 3 is congruent to angle 4? So here's angle 3, here's angle 4. So these to me look like alternate interior, as long as Jefferson Street and Eagle Road, or sorry, that's Washington Street, isn't it? Eagle Road's this one. So Washington Street and Jefferson Street, as long as they are parallel. So Washington and Jefferson must be parallel. Okay, and then the last question, if the measure of angle 1 equals 90, so if the measure of angle 1 equals 90, and your answers to parts A and B are true, so these are both true, to what roads is Eagle Road perpendicular? So if this is true, and if this is true, then this is parallel to this, and that would mean Eagle Road would be perpendicular to Washington, Lincoln, and Jefferson, because it would be 90 here, and then in order for these to be parallel, it would also be 90 here. So Eagle Road would be perpendicular to Washington, Lincoln, and Jefferson. Washington, Jefferson, and Lincoln. Okay.